Hi guys, so welcome ulit sa ating YouTube channel. Ito na yung lesson 28 sa ating complex analysis. This is all about the Taylor series. Okay, so let's have theorem. Suppose that the function f is analytic throughout the disk. So z minus z naught is less than r naught. So meaning z naught is the center, then r naught is the radius. Then f of z has the power series representation. So again, kung analytic ka sa isang open disk, okay, then yung f of z has the power series representation. So, imagine mo, sir, sa isang open disk lang ba ako analytic? Hindi. Marami, analytic ka sa lahat. So, ang tinitake lang nito is at some point. So, ganito kasi yun. Pag continuous ka tate, check natin yung epsilon distance. So, nangyari, check natin yung epsilon distance niya, tapos yung mga neighborhood. Tapos, kung napakaliit as epsilon distance, kung baga nagkaroon ka ng epsilon distance or delta distance na napakaliit, then therefore, continuous ka. So, almost tumutok yung point, yun ibig sabihin. Yung dito naman, ganun din ibig sabihin. Dito naman, ang gagawin natin, through power series. Okay, so sa power series naman, is gagawa lang tayo ng parang region of convergence niya. So kung ang nangyari is less than, kumbaga dito is, ang pinagkaiba nila, dun sa function, sa continuity, ang nangyari is epsilon distance. Dito naman, walang regardless. Kumbaga, gaano kalaki man yung radius niyan, okay lang. Kasi nga may region of convergence naman eh. Okay, so i-check natin continuous ba yung function or analytic. Meaning kasi na analytic sa atin is differentiable eh. Okay, pero di ba pag differentiable ka, automatic continuous ka. Diba ganun yung mga idea niyan. Okay, so let's have this then f of z has the power series representation. So again, ito yung power series representation f of z is equal to the summation of a sub n times z minus z naught raised to n, for n is equal to 0 up to infinity. Again, power series pa lang yan. So, lahat ng pag-uusapan natin. So, ang ibig sabihin, lahat ng function kaya kong i-represent into a power series. Wherein, yung z minus z naught is less than r naught. So, ayun nga, yung radius na tapos may radius tapos may center. Where, yung a sub n is equal to f nth derivative of z naught over n factorial. Okay, so ulit na, f nth derivative of z naught over n factorial. So, meaning, differentiate muna at saka mo evaluate at z naught. So, where, lagi ko na dito, dagdag ko na, pag nangyari, f raised to 0 yan, of z naught, that is just equal lang sa f of z naught. So f1 that is f prime, f2 that is f double prime, f3 that is f triple prime. Yun yung ibig sabihin yan. Okay, so that is the series converges to f of z when z lies in the stated open disk. So nung open disk yun, drawing ko lang para imagine. So pagpasensyahan nyo na yung drawing niya, sir. Okay, so ang gagawin ko, mag-drawing ako ng z naught ko somewhere dito. Okay, with radius r naught. Okay, so ang sabi niya, when z lies in the stated open disk. So meaning, pag nagla-lies, even dun sa outside ng circle, dun sa circumference ng ating open disk. Since open disk, broken siya. So I think alam niyo naman yung pagiging open saka close pag din na drawing. Okay, nandito si z somewhere. Sorry, andito pala sa loob. Okay, so somewhere na sa loob siya. Kasi pag dyan pala open disk, no, ibig sabihin hindi kasama. Yan pala ibig sabihin ng pagiging open. Okay, so lies dun within sa loob ng open disk. So meaning converges ka. Yung f of z, when z lies dun, converges f of z. Okay, saan bakit nasabi mo converges? Kasi ano nangyari? Kasi dati ganito sa advanced calculus. Sa advanced calculus or sa real number nyo, ang ginagawa, yung function magiging continuous pag mayroong sequence. Kunyari, yung function magiging continuous sa C, let's say sa C, pag meron kang na-create na sequence na nagtetend sa C. Tama. Dito naman, yung function magiging analytic or somewhat continuous na rin kung meron kang power series. So, yung series natin, aware tayo na, kung yung series nagko-converge, so aware tayo kung series nagko-converge, kung yung series nagko-converge dun sa, nagko-converge siya, meaning continuous siya. So, ito pinagkaiba. Dito, gagawa tayo ng power series or ng series na kung saan dapat magko-converge or dapat may lalabas na value. Then, ibig sabihin nun, nakakagawa ka ng f of z. Yun yung ibig sabihin niya dito. Okay, although sa real number, pwede rin ganito rin gawin kasi may Taylor series din sa Maclaurin series din doon, gumagawa rin doon. Same sense lang. Pero, ayun nga, ito nga, ginagawa naman dito, laging open disk eh. So, lahat ng complex number, may open disk talaga na nabubuo. So, dito, mas madali kasi makreate dito yung, kumbaga, mas madali mo makita dito yung neighborhood, yung epsilon distance niya. Kasi nga, dito nga is lahat ng complex number, nakaka-form nga tayo ng open this. Okay, so again, punta muna tayo dito. Let's have the Taylor series. So the Taylor series f of z at z naught. Okay, so palit ko na yun doon. So the Taylor series f of z at z naught, so meaning meron z naught, is f of z is equal to summation for n is equal to 0 up to infinity ng f raised to n. So f nth derivative of z naught over n factorial times z minus z naught raised to n. So yung mga importanteng part talaga na is totally ito. Dapat nakikita ko to. So dapat makita mo yung z minus z naught raised to n. So malalaman mo na nakabuo ka ng series o ng power series niya, specifically Taylor series niya, kung merong z minus z naught raised to n doon na nag-exist. Okay, note, ang tawag dito is compact form. Okay, meaning ng compact form is naka-summation form. So pag in-expand ko kasi yan, iba ibig sabihin. Tama? So try ko na expand. Ang expanded form niyan is f of 0 z naught over 0 factorial. Tama? Then z minus z naught raised to 0 plus f prime of z naught over 1 factorial. Then z minus z naught raised to 1 plus f double prime kasi ito na of z naught over 2 factorial, then z minus z naught raised to 2 plus dot plus. Okay, so ito yung tinatawag ng expanded form. Okay, o yung series representation niya. Okay, ito naman series representation pa rin pero compact form kasi nga naka-summation na, kumbaga mas maliit. Kumbaga mas madali siyang i-drawing. So kung mas madali kang maka-analyze based dito, okay lang. Kung di mo ma-analyze, i-expand mo para mas makita mo. Okay, so again that is at z naught, where z naught is not equal to 0. Next, the Taylor series f of z at z is equal to z naught is equal to 0. At z naught is equal to 0 rather, would be ganito, summation of nth derivative over n factorial of 0 z raised to n. So, anong nangyari? But yung z minus z naught, that is z minus 0, kaya naging z raised to n na rin. Power series pa rin siya, pero ang special tawag sa kanya is Maclaurin series. So, meaning, kung kinuha natin yung power series representation ng function doon sa mismong center o doon sa origin. So, yun yung una kong gagawin dito sa video na to. Kukunin muna natin yung mga Maclaurin series, then sa next video, Taylor series naman. Okay, so para, ang gagawin ko kasi is, i-derive ko lahat ng mga Taylor series, tapos saka natin kumbaga revise na lang gamit yung mga Taylor series na yun, meron tayong magagamit na mga expansion niya. Okay, so let's have example. So sabi, obtain the Maclaurin series for the following. So ito, mag-uumpisa ako sa pinaka-basic dun sa actual way. So kung paano siya is solved manually. So after that, makaka-form ako ng compact form niya, into which gagamitin ko yung compact form para ma-derive ko si sine, si cosine, ito, tapos yung iba. Kumbaga, dahil i raised to z, makuha ko lahat ng idea kung paano makapag-create ng Maclaurin series na hindi dumadaan sa ganitong method, yung ganyang kahaba. Okay, so for the meantime, yung method mo na lang yung gagawin. Since of Maclaurin series yung ginagamit, ang gagamitin natin formula, o yung Maclaurin series yung pinapahanap, ang gagamitin formula is ito. Okay, so let us find the Maclaurin series representation of e raised to z. So we have e raised to z is equal to summation for n is equal to 0 up to infinity ng nth derivative of 0 over n factorial, then z raised to n. Okay, then next is expand ko yan, that is equivalent, dito ko nalagay para medyo mahaba yung aking form, that is equivalent sa f of 0. So f0 derivative over 0 factorial ng z raised to 0 plus f first derivative at 0, then 1 factorial, then z raised to 1 plus f double derivative at 0 over 2 factorial ng z raised sa 2, then plus this is f third derivative at 0 nung 3 factorial, then z raised to 3 plus that. Observe natin ano nangyari. Ulitin ko lang to. This is f nth derivative of 0 over n factorial, then z raised to n. So nilagay ko lang guys yung parang dulo niya. Okay, next is, syempre evaluate natin yung f of 0. So ano yung f of z natin? F of z natin is e raised to z. So ano yung mga derivative niyan? So ang first derivative niyan is 0. So dito ko lang lagay Yun na, si f of z is equal to e raised to z. Okay, yung first derivative niya is e raised to z pa rin. So up to f nth derivative is equal to e raised to z pa rin. Tama? So kung napansin mo, kada palit ko niyan, yan pa rin sagot niya. Ngayon, ito ang gagawin natin sunod. Ang gagawin natin sunod, at z is equal to 0, ang lahat ng sagot dyan, e raised to 0, e raised to 0, e raised to 0, ang lahat ng sagot dyan is equal to 1, 1, and 1. So basically, lahat ng f of 0, f derivative of 0, f first derivative of f at 0, second derivative of f at 0, third derivative of f at 0, and nth derivative of f at 0 is always equal to 1. So meaning mawawala sa lahat, disregarded. Okay, so sumaklo rin niya. So therefore, this is just z raised to 1, z raised to 0 is 1 over 1. Plus, dito lang is z raised to 1 plus z raised to 2 over 2 plus z raised to 3 over 6 plus plus z raised to n over n factorial. Okay, wherein ito yung kanyang expanded form, okay, ng Maclaurin series na e raised to z, in which yung kanyang compact form, yung e raised to z natin, yung kanyang compact form is just the summation for n is equal to 0 up to infinity ng z raised to n over n factorial. Okay, so therefore ito yung kanyang Maclaurin series representation. Although ito rin Maclaurin series representation, pero mas gusto ko lang lagi si compact form. Mas madali. So again, pag nakita ka ng e raised to z, ito agad yung sagot mo dyan. Okay, so that is e raised to z. Okay, ngayon, paano gumagana yung e raised to z na yan? So, for example, ang ginawa ni sir, for example lang kunyari, pinakuha ko yung Maclaurin series representation ng 2z. Ang mangyari lang, yung z na yun, i-replace ko lang yung z sa loob ng 2z. So, ang mangyari, this is just equal sa summation for n is equal to 0 up to infinity ng 2z raised to n over n factorial. Then, simplify further, that is summation for n is equal to 0 up to infinity ng 2 raised to n z raised to n over n factorial. So, ito yung kanyang compact form o yung kanyang Maclaurin series representation. So, napakalaking tulong nito. So, parang ito yung basis ko. So, kunyari nagkaroon ako ng z squared, papet ako ng z squared yun. Ganun lang kasimple. Tapos, simplify ko lang further sa loob ng summation natin o summand natin. So, ito yung una nating basic. Okay, so, through that, i-derive naman natin si sine, si cosine, then si sa dulo. Okay, next. Number 2. F of z is equal to sine z. So, dito, parang imposible makuha mo papunta dyan, no? Kumbaga, sir, paano mo gamit si e raised to z? Remember that sine z is equal to, kung naaalala ni sir, na si sine z is equal to e raised to I minus e raised to negative I over 2i. E raised to z. E raised to iz tapos e raised to negative iz over 2i. Yan yung ibig sabihin niya. Tama. Ngayon, ang gagawin ko, since nakita mo may e raised to something, magagamit ko yung idea ko doon. Tama. So, ang gagawin ko, this is just equal. So, kunyari, gusto kong kunin yung kanyang summation form, gamit to. So, ang mangyari, ilalabas ko lang yung 1 over 2i. Pa-factor out ko si 1 over 2i. Tapos, may matitirang e raised to iz minus e raised to negative iz. Ngayon, ipapalit ko yung iz saka negative iz dun sa loob na yun. Okay, then, this is equal. So, 1 over 2i multiplied by, this is summation. Okay, for n is equal to 0 up to infinity. Yung una, yung z ko is iz. So, ito ay iz raised to n over n factorial pa rin syempre. minus summation for n is equal to 0 up to infinity ng negative iz raised to n over n factorial pa rin. Okay, next is simplify ko further rin nasa loob ng summation natin. Kunyari, okay, hindi natin basta-basta masasabi. Sorry, hindi ko basta-basta mapaparehas pala. Okay, ganito. This is equal sa 1 over 2i, then summation, this summation for n is equal to 0 up to infinity ng I raised to n, z raised to n over n factorial minus summation for n is equal to 0 up to infinity ng negative I raised to n tapos z raised to n over n factorial. Okay, ganito gagawin ko. May common sila na I raised to n. Si I raised to n yan, actually, affected naman siya totally talaga dun sa loob nung ating summation. Tama? So, affected siya. Pero, ang gagawin ko, ipa-factor out ko lang siya somewhat. Or parang ganito. Gawin ko na nga. This is 1 over 2i. Then, this is multiplied by summation for n is equal to 0 up to infinity. Ilalabas ko tong nakikita ko, si I raised to n minus negative I raised to n. Okay, then isasama ko na z raised to n over n factorial. Kumbaga pinagsama ko lang. Okay, kumbaga pinag-isa ko lang ng summation kasi almost parehas naman. Kumbaga pinactor out ko, nilabas ko lang, tapos andyan lang sa loob. Okay, ngayon, observe natin tong values na to. Yung I raised to n minus negative I raised to n. Pag add, observe natin si I raised to n minus negative I raised to n. If n is odd, ano mangyayari dyan? If n is odd, this is always negative 1. Tama? Okay, so somewhere, lagi yung may negative 1. Okay, so ay nga no, kung n is odd, ito ay laging negative. Ano to, negative 1 to, somewhat may negative to, somewhat may negative I to, kasi nga may I squared na kino-consider eh. So kunyari I cube, so if n is equal to that is negative I, tama, that is always negative I. Okay, minus if n is odd also, this is always positive. Since may negative, so pag in-add ko, that is negative. Tapos yung I, okay, ulitin ko nga, ising nga, this is I raised to n minus negative 1 raised to n, tapos I raised to n. Yan, pinaghiwalay ko lang para mas ma-imagine natin lalo. So I raised to n, negative I yun, tama, lagi kasing may negative I dyan. Tapos pag ito naman, ito ipag-add, that is always negative 1. So sure ako lagi itong negative 1. Okay, tapos yung I raised to n, that is negative I din. Tama. So, basically, ano yung magiging sagot dyan? That is negative, that's negative, that's always negative 2i. Okay, so pag n is odd. So, paano pag n is even? Pag n is even, so, ano yung magiging sagot dito sa I raised to n? Sa I raised to n, lagi siyang negative 1. Sure ako, no? So, lagi siyang sure na negative 1 or depende sa value, no? For I raised to n, hindi naman lang. Kanyari, I raised to 2. I raised to 2 is negative 1. I raised to 4 is positive. Nagpapalit. Tama, nagpapalit siya. Pag even siya, anong nangyayari? Kanyari, in-even ko, Kanyari, naging ganito. I raised to 2k minus negative 1 raised to 2k. Tapos, I raised sa 2k. Yung I raised sa 2k, factor ko yung I squared. That is parang laging ganito. Negative ng I raised to k minus, so parang binalik mo nga lang, to be honest. Tapos ito laging positive. Siyempre lagi na itong positive. Tapos ito ay I raised sa 2k something. Plus, magiging plus kasi negative yun. Okay, so pag even, this is always 0 naman. So, anong nangyari doon? Nagsi-0 siya pag even. So, ano ibig sabihin? Iiwasan natin yung part na mga even. Kasi pag even, nagsi-0 yung somewhat sa part niya. So, kumbaga, yung term na even term is 0. Kunyari, for n is equal to 0, even siya. For n is equal to 2, even siya. 0 siya. 0 yung lumalabas na term nung ating Maclaurin series. So, ano ibig sabihin ko dito? Ang gagawin ko, kukunin natin yung term na dapat add lang siya. Okay, so, ibig sabihin, para makuha yung add na yun, magiging 2i lang to. Okay, so, ang gagawin ko, siyempre, mag-i-start na lang ko for n is equal to 1, hindi na sa 0, kasi nga gagawin kong add eh. So, this is equal sa 1 over 2i multiplied by summation for n is equal to 1 up to infinity. Ito, ginawa ko ng add, so ito ay naging 2i na. Okay, multiplied by z raised sa 2n plus 1 over 2n plus 1 factorial. So, sure ako, kinukuha ko na lagi yung add. Again, add na yung kinuha kong number dyan. Ngayon, yung 2 ay lalabas dyan, maka-cancel out lang. So, therefore, ano yung sin e raised to c natin? Therefore, yung sin c natin is equal to summation for n is equal to 1 up to infinity ng z raised sa 2n plus 1 over 2n plus 1 factorial. Okay, so ito yung kanyang Maclaurin representation. Okay, so hoping na naintindihan mo yung part na pinakita ko sa inyo doon. Okay, next. Ito talaga yung mahirap dito, yung mahaba siya explain. Next is f of z is equal to cosine z. So note na yung derivative ng cosine z is just, note na yung derivative ng sin z is cosine. So what if kunin natin yung derivative nito para makuha natin yung limit nito. Okay, so ano ibig sabihin sir? Di-differentiate ko lang sa loob ng summation. So paano mangyayari doon? So di ba gusto natin kunin yung cosine c? So note that cosine c is just equal sa derivative ng sin c. So meaning, kunin na lang natin yung derivative ng kanyang power series. So with respect sa z siyempre, nung summation for n is equal to 1 up to infinity ng z raised sa 2n plus 1 over 2n plus 1 factorial. Okay, kunin natin derivative niya with respect sa c. So obviously constant to, ito lang yung mga apektuhan sa loob. Okay, so this is just equal sa summation for n is equal to 1 up to infinity. Bababa yung 2n plus 1, no? That is 2n plus 1. Tapos z raised sa 2n minus 1. 2n plus 1 minus 1, that is 2n na lang. All over 2n plus 1 factorial. Okay, by derivative. Next is cancel yung 2n plus 1. May matitirang 2n factorial sa ilalim. Okay, so therefore, so mayroon ganito, no? This is summation for n is equal to 1 up to infinity ng 2n plus 1 z raised sa 2n over 2n plus 1 tapos 2n factorial. Okay, so cancel yung 2n plus 1. Therefore, lagay ko na lang yung Maclaurin representation ng cosine z is just summation for n is equal to dito naman napansin mo even na yung term 2n. So dito pwede natin kunin for n is equal to 0. So for n is equal to 0, for n is equal to 0 up to infinity ng z raised sa 2n over 2n factorial. Okay, so tama naman sa Maclaurin series, si sine at si cosine alternating sila kay e raised to z. Okay, kasi sila galing lang sila kay e raised to z. Si e raised to z yung whole term. Kunin mo yung mga even term nun. So kunin mo yung mga even term nun, that is the cosine c. Okay, kunin mo yung odd term nun, that is the sin c. Okay, yun yung Maclaurin representation ng sin c. Kasi nga, dun din sila galing talaga kay e raised to z. Okay, so ito yung compact form natin for cosine. So napaka-useful nito. Kung paano ko ginagawa kanina kay sine, nakita nyo kay e raised to z. Kunyari, pinalitan ko ito ng 2z, papalitan ko lang ng 2z yan sa loob, then operate na ng konti. Kunyari, ginawa kong z raised to 5, z raised to 5 palitan mo, then raised to 2n pa rin. Okay, so hoping na naintindihan mo yung idea. So again, saksak nyo na sa isip to, na ito yung mga Maclaurin series representation nila. Tapos, thank God kasi nakuha ko siya nang hindi ko inaalala din. Kasi nakalimutan ko na rin to be honest. Kasi galing pa ako ng discussion ng set degree, kaya talagang inakabahan din ako i-discuss siya ngayon. Although kailangan ko na i-discuss kasi kailangan ko na mag-upload by tomorrow. Okay, so for number 4, let f of z is equal to 1 over 1 minus z. Ito ay napaka-useful, fixed to fixed. So, gagamitin natin to sa mga susunod na example ko, lalo sa mga Laurent. Okay, so ganito naman, paano ko siya i-derive? Hindi ko gagamitin ito, by the way. Hindi ko pala gagamitin yung mga yan kasi hindi siya manggagaling sa e raised to z. Manggagaling siya dito. So, consider natin muna to. Consider si summation for n is equal to 0 up to infinity ng z raised to n. That is equal sa z raised to 0. Tama ba? Z raised to 0. Sorry, baliktad. C7. Z raised to n. Okay, z raised to n. That is z raised to 0 plus z raised to 1 plus z raised to 2 plus plus z raised to n. Okay, so obviously, siya ay infinite geometric series. Sir, bakit mo nasabi na infinite geometric series siya? So, kasi, ang ratio niya is z over 1, which is equal sa z squared over z, which is equal sa z cubed over z squared. Okay, which is equal sa z. Tama. Then, yung kanyang first term, so ano ba yung first term niya? Ang kanyang a sub 1 is 1. Kasi z raised to 0. Okay, so ano yung formula ng sum nun? Ang formula ng sum niya is equal to a sub 1 minus 1 minus r pag infinite geometric series. So therefore this is equal sa 1 over 1 minus z. So napansin mo, yung sum nila is just equal sa function na yun. So meaning ano yung Maclaurin series representation ng 1 over 1 minus z? Yung Maclaurin series representation ng 1 over 1 minus z is just equal sa summation for n is equal to 0 up to infinity ng z raised to n. So ito ay napaka-useful din. So, ganun din, kunyari pinatang ko yung z. Kunyari, ginawa ko lang tong 1 over z. Paano natin kukunin si 1 over z? Using this. Yung 1 minus z, papalitan natin yung z ng, paano ba siya maging, ng 1 minus z. Ito ko lang yung 1 over 1 minus z, papalitan natin to. Diba? Dito tayo galing. Para mo ko yan. So, ito ay equal sa 1 over 1 minus 1 minus z. Tama? Kasi 1 minus 1 tapos positive 1. Okay, so pag in-apply ko doon, so ito yung z natin dyan. So kunyari parang ito yung z, lumalabas na z para dito. So ipalit natin siya doon. That is simply equivalent lang sa summation for n is equal to 0 up to infinity ng 1 minus z raised to n. So meaning yung Maclaurin series representation ng 1 over z natin is ito. Okay, so tamang adjustment lang para makuha mo yan. Values na yan. Okay? Okay, next example is the f of z is equal to sinh of z. So, ano naman yung sinh of z in terms of e? So, kung naalala ko, si sinh of z, si hyperbolic sine of z is equal sa e raised to z minus e raised to negative z over 2. So, wala nang involved na, tawag dito, wala nang involved na function. I mean, wala nang involved na I. Okay, so, pag inayos, this is just equal sa 1/2, then e raised to z minus e raised to negative z. Then, kunin natin yung Maclaurin representation ng dalawa. This is equal sa 1/2 multiplied by summation for n is equal to 0 up to infinity ng z raised to n over n factorial para dyan minus summation for n is equal to 0 up to infinity ng negative z raised to n over n factorial. Okay, so consider lang din natin ulit yung isa. Ano mangyari dyan? Ang mangyari, may negative 1 raised to n doon. Okay, so may dalawang klase na naman mangyari. 1 minus negative 1 minus negative 1 raised to n. So ulitin ko lang muna. So this is equal sa 1/2 multiplied by summation for n is equal to 0 up to infinity ng z raised to n over n factorial minus summation for n is equal to 0 up to infinity ng negative 1 raised to n tapos z raised to n over n factorial. Okay, so again, factor out ko ulit yung mga summation na yun, tapos kunin ko lang yung values na yun, yung gusto kong mangyari. So this is 1 half. Then summation, this is summation for n is equal to 0 up to infinity ng merong 1 dito sa una minus negative 1 raised to n. Okay, then this is z raised to n over n factorial. Okay, so observe ulit natin. Pag n is even, mas madali. Pag n is even, this is positive. So meaning 0 siya. 1 minus 0, disregarded. So ibig sabihin, pag singe, add din. So kukunin natin for n is equal to add. So for n is equal to add, for n is equal to 2n plus 1, or ginawa kong add, yung 1 minus negative 1 raised to n is equal to 2. Okay, so kasi kukunin natin. So ibig sabihin, iset natin lahat ng n is even, then ito, for n is equal to 1 na mag-start. So yung 2 na yung lalabas ko doon, so magiging 2 over 2, then summation, for n is equal to 1 up to infinity ng z raised to 2n plus 1 over 2n plus 1 factorial. So therefore, ito yung singe of z. Okay, so ayun yung kanyang compact form. So kung gusto mo lang, mawala tong 2, no? So cancel yan. Mawala yung 2 na yun kasi cancel na lang. Kasi this is 2, cancel siya dun. Try ko na lang, no? 2 dito. So ito ay cancel. Para hindi mo makana. Okay, so ito rin, another thing. Laging compact form yung binibigay ko. Pero pwede mo siya i-represent pa rin as series, Maclaurin series representation. So tulad na ito, ni sine saka ni cosine. Ano yung tsura ni sine saka ni cosine? Ano yung tsura ni sine saka ni cosine? Pag kay sine, start tayo sa 1. So z raised to 3. Kunyari, start tayo sa 0. Kaya lang, pag nag-start sa 0, kuha naman to, no? Pag start sa 0. Okay. Tama lang. Gato pakipalitan to. Mag-start pa rin ako dapat sa 0 dito. Okay, kasi term lang to eh. Okay, so nangyari, yung 2n plus 1 na yan, yun ay nagsiset nung sa loob. Dito, 0 pa rin to. Yun ay konting error na sa doon. So ngayon, ito gagawin ko. Si sin z, okay, equal siya sa, kunyari, in-expand ko to. Kunyari, in-expand ko yung part na yan. That is z raised, kunyari, for 0 siya, that is z raised to 2 times 0 plus 1, that is z, over 2 times 0 plus 1, that's 1 factorial. So that is z lang. So this is z. Sunod, plus. Okay, so plus. Ano yung sunod dyan, plus? I think plus. Ayun, may nakakalimutan ako ilagay. Okay, ito pansinin ko lang para maayos ko rin. May ko lang napansin. 'Di ba, sinet ko siya as add. Ngayon, nung sinet ko siya na add, that is always negative 2i. Tama, sabi ko. Pero naka-raise yung i din pala sa n. Okay, so ang mangyari pala literal sa kanya is magkakaroon tayo ng somewhere na ganito, no? Parang 1 minus negative 1 raised to n. Tapos I raised to n. Din pala yung simplified form sa loob na ito. Okay, so again that is 1 minus, nilabas ko yung I raised to n, pinactor out ko, so may natirang negative 1. Okay, so nung nilabas ko yan, pag ito add, this is always negative 1. Ako din, pag ito ay add, this is always 2. Okay, next, pag ito ay add, yung 2n plus 1 I raised to 1, ito naman ay laging, di ba? Ito ay magiging I raised to 2n plus 1. Okay, into which magiging kumbaga magiging negative 1 raised to n tapos times 2. Tapos may I pa. Sorry, kasi may isa pang I doon. Kasi I raised to 2n, since meron ng 2, I raised to n raised to 2 is always negative 1. So kaya negative 1 raised to n na lang, yung I raised to 2n yan, that is negative 1 raised to n. Tapos yung 2i, ito yung I raised to 1, yan yung 2i. So meaning yung 2i, pinactor out ko, kaya mapapactor ko. So dito, may konti akong Actually, napakalaki kasi importante siya. Nakita ko rin kasi alternating yung sign eh. So, dito, supposed to be, meron ka pang negative 1 raised to n sa loob. Kasi alternating to. So, since may negative 1 pa dito sa loob, burahin ko lang konti. So, dito ay may negative 1 raised to n. Tapos ito ay 2i. Okay, so meaning, ayusin ko lang dito, singit ko na lang, this is negative 1 raised to n, meron pa dyan sa loob. Dito rin, ganun din, kasi nga meron pang negative 1 raised to n dito. So meron pa akong negative 1 raised to n, so hindi naman maapektuhan yan. That is negative 1 raised to n. So ito ay, meron pa rin negative 1 raised to n. So ayusin ko na lang ulit. Yung sign sila natin, sorry, buti nakita ko. That is summation for n is equal to 0 up to infinity ng negative 1 raised to n for z raised to 2n plus 1 all over 2n plus 1 factorial. Ito yung tama. Yung cosine sila natin, that is equal sa summation for n is equal to 0 up to infinity ng negative 1 raised to n ng z raised to 2n over 2n factorial. Okay, so ito yung consider natin. Wag yung, hindi ko kasi na-edit na. Okay, so again, hindi ko kasi na-imagine yung i na yan. Kasi, di ba yung i raised to n minus i, negative i raised to n. Pinactor out ko yung i raised to n. Ngayon ko lang din napansin. Factor ko yung i raised to n, may terang 1, may terang negative 1. Pero negative 1 raised to n pa rin yun. Ngayon, 1 minus negative 1 raised to n. Kung ito ay add, ito ay laging plus, ito ay laging negative. So, 1 minus negative, that is 1 plus 1, which is 2. Ngayon, may, ginawa ko ng n, kumbaga, ginawa ko na siyang add. So, nangyari, that's i raised to 2n plus 1. Ngayon, yung i raised to 2n plus 1, ito yung nangyari. Yung i raised to 2n plus 1, that is i raised to n raised to 2 times i raised to 1. Yung i raised to n raised to 2, naging yung ito yung naging negative 1. Okay, so, abagtad. I squared raised to n. So, I squared, that is negative 1 raised to n. Kaya negative 1 raised to n. Tapos times 2i. Kasi may 2i pa dun. Dun yung nangyari sa i raised to 2n plus 1. Kaya ganyan. Tapos ngayon, pinactoral ko yung 2i. Pinactor ko dun. Then, kinancel ko yun dun. Okay, so, hoping na nakita mo yan. Sorry about that. Di ko rin napansin. Then, pakiayos ha. Tandaan, ito yung tama na ating Maclaurin series. So, that's all for this video. Hindi ko na itutuloy yung sinasabi ko dito. So, papakita ko rin naman. So, itong ibig sabihin lang ng sign. So, dito is negative. Kasi nga, chinek ko kanina eh. Ito is z minus, kasi negative alternating. For n is equal to 0, kasi start tayo sa 0, sorry. For n is equal to 0, this is 1. So, for n is equal to 1, negative na yun. So, that is negative. Negative z cube. Negative z cube over, that is 1 na to, no? 1 plus 1, that is 3. 3 factorial plus z to the 5th tapos 5 factorial minus z to the 7 over 7 factorial then plus that minus. Yan yung ganyan expanded form niya. Pag si cosine naman, baliktad. Si cosine z naman is una, for n is equal to 0, syempre positive pa rin siya. Pero that is 0. That is 1. Kasi z raised to 2 times 0 is 1. 2 times 0 factorial is 1. Ito yung una. Then minus z squared over 2 factorial plus z to the 4th over 4 factorial minus z to the 6 over 6 factorial plus z to the 8 over 8 factorial. Then plus plus, minus plus. Okay, kung napansin mo, alternating sila ni e raised to z. Pag si e raised to z, in-expand ko ng buo as a whole, walang alternating na negative. So, kunyari, positive ko lang lahat to, tapos pagsamahin ko, siya yung buong e raised to z. Okay, so yun yung ibig sabihin lang ni sir. So again, ito kaya ko na expand. Ito rin, similar dito. Okay, so tandaan na, sana ito yung mga recognize. So sana tinatapos mo kasi ito yung tamang Maclaurin series representation ng cosine saka sine. Okay, so that's all and thank you for watching. Hoping na panoorin mo next video kasi next video is more about example ng Taylor series in which dadagdagan konti ng idea tapos kunin natin dyan.